Alrighty, class, let's talk about color. And we're going to talk about the three main color spaces that you'll encounter when you're processing your raw images. And to help us in those illustrations, we're going to turn to these two fine boxes of Crayola crayons. We have one that's 64 crayons in it and another one that has 96. And if you'll think of the 64 box of crayons as the sRGB color space, and then if you'll think of the 96 count box of crayons as the Adobe RGB color space, and then I'm going to confuse you just a little more. If you take these two boxes and then combine them and take some of the colors, mix them together for still new colors, you'll have what's known as the ProPhoto RGB color space. And to help illustrate how that works, let's take a look at this graphic, and we'll see that this 2200 matte paper is a color space that's kind of superimposed on this to give you an idea as to the breadth of colors that this particular photo paper can reproduce. So we're not going to discuss it too terribly much. The sRGB color space is the smaller of the three. It was invented in the early 80s, late 70s as a way to kind of standardize the colors that a computer monitor could reflect at that point in time. Adobe RGB was invented in 1998 by, you guessed it, Adobe, as a way to allow software programs to process the breadth of colors that were coming in off of digital cameras that were becoming more and more prevalent. The ProPhoto RGB color space is huge, and it comprises almost about 85% of the visible light spectrum, as we can see here. This little egg-shaped thing that's sitting at the bottom of this triangle composite is represented as the visible light spectrum the human eye can pick up. Now, most color monitors these days, in fact, just about all color monitors, can capture and reflect the sRGB color space. In fact, it's the default color space whenever you convert something to a JPEG format. Adobe RGB, being a larger color space, means that the color monitors that can capture and display this color space are, for obvious reasons, more expensive. Now, there are color monitors, $350, that can reproduce the Adobe RGB color space, but they're inexpensive by comparison. They're not going to be terribly stable from a color standpoint. So if you want something good that's going to approximate most of the Adobe RGB color space, you have to spend starting about $700–800. And I've seen them as expensive as $12,000 in the medical profession. But if you go up to between $800 and $1,500, you'll get a very, very good monitor that'll reflect 90 to 100% of the Adobe RGB color space, and you'll have a very, very good monitor indeed. There are no monitors that can reflect the ProPhoto RGB color space. It's just way yonder too big. So that's the thumbnail sketch of the color spaces. Let's now look at another utility that will help us connect all these dots and make some sense out of what you've learned so far. And if you're on a Mac, there's a handy little utility that's on here, and we come down to the Applications folder, click on it, and scroll down to the Utilities. There'll be an app in here called Color Sync Utility. Click on that, and we see this 3D graphical representation of the color spaces. And I'm going to go up here and just clear this. And of course, this is sRGB, and as I mentioned, any computer monitor can give you the colors that are located in this color space. Now we're going to go up from there and go to Adobe RGB, and we can instantly see that it's physically larger. It carries more colors. So let's take this and hold it for comparison. We'll create a wireframe for reference, and then we'll take sRGB and compare the two. And we can see immediately that the Adobe RGB color space contains all of the colors in sRGB and then some. Okay. Now, let's go to Adobe, clear the comparison. And now for the ProPhoto RGB, look how large that is. It's enormous. Again, representing about 85% of the visible light spectrum. So we're going to take this, hold it for comparison, and then put the Adobe RGB inside. And so you can see that all of the Adobe RGB color space fits inside the ProPhoto color space. It's all encompassed in there. And then look at sRGB. Certainly everything in sRGB fits in the ProPhoto color space. So what does all this mean to you from the standpoint of processing your images? Well, let's take a look. Reduce this. Now we're going to go to a program called DxO Photo Lab. Notice here we're setting up our export dialog box, and we have TIFF designated, non-compressed TIFF, 16-bit, full size, meaning it's not compressed at all. And we have assigned the ProPhoto RGB color space to this image. And that means that we're going to capture every bit of color information that came off that sensor and convert it into the image. And then we're going to later take it and put it in Photoshop for final output processing. Now, you might use Lightroom, you might use something else, but for my purposes, I always go to Photoshop. And so I want all of that color information in there. So I'm going to process the TIFF image at the ProPhoto RGB color space. Now let's go to Photoshop and show you what happens when we get there. And I'll direct your attention to Edit, and then Color Settings, and the dialog box that comes up has a space called Working Spaces. And notice here that the working space, in other words, it's the space right here where the image is going to be processed. The working space is assigned at ProPhoto RGB, which means that we'll take the raw conversion to a TIFF into Photoshop with all of the color information that came off that sensor. Every little shred of color detail that came off that sensor is going to be included in that file, placed into Photoshop for final output processing. Now, since I have you here in this dialog box, I may as well direct your attention to the gray setting under Working Spaces and just set this at Gray Gamma 2.2. Your black and white images will look a lot better if you'll do that. Color management policies. You want to set this to preserve embedded profiles, not convert to working RGB. You want to preserve embedded profiles. Let's say you have an image that was shot with a simple point and shoot, and Grandma wants you to enlarge this image so that she can have a picture of the family on her dressing table. And you take the image out of her point and shoot. It's an sRGB JPEG, and that image will never have more colors in it than are represented by the sRGB color space. But you still want to capture everything that her camera was able to capture, so we're going to put it inside the ProPhoto RGB color space. Think back to our previous display when we had that 3D model that showed that the RGB color space fit inside the ProPhoto RGB color space. We're getting every shred of color information that camera can process. So you want to preserve embedded profiles for RGB, CMYK, and also grayscale. Now, for you Lightroom users, let me show you something you may or may not be aware of when it comes to exporting your image. Now, we've got this image of El Capitan in Yosemite National Park. We've done our adjustments on it. We're ready for it to proceed to the next step in processing. Notice here it is a RAW file, so we need to put it either as a TIFF or a JPEG. I would strongly encourage you not to convert it to a DNG. That's another conversation, but a TIFF or a JPEG is 99% of what people do. So we come over here, we click on Library, we come down and click on the Export tab, and we get the dialog box that comes up. You'll see here where JPEG has the default color space assigned to it as sRGB, and that's as it should be. That's correct. Now, if you wanted to export it as a TIFF, look what Lightroom does. We come down here, we click on TIFF, and it exports it as ProPhoto RGB color space with no compression, 16-bit TIFF image, which you can then put into Photoshop, you can put it in Luminar, whatever it is you want to do to it from this stage. But the point is that Lightroom knows that if you're going to convert this to a TIFF, it needs to be in the ProPhoto RGB color space because, again, it's capturing all of the colors that are in this raw file. So there you go. Understanding the color spaces is really going to help you when you do your processing. Now, what's the next step? Okay, you're going to put it into Photoshop, you're going to put it in Luminar, you're going to do other things to it as a TIFF in the ProPhoto RGB color space. Now, once you've done all those adjustments and you export it into sRGB, when that conversion process completes, you're going to have a much, much higher quality JPEG as a result. It's the old saying, garbage in, garbage out. You've heard that. So you put the highest quality image into the sRGB conversion process, you're going to get much, much better results out the other end, thereby making your image look much, much better than it might be with a different color space. So there you have the 3 color spaces. Definitely concepts you need to understand in order to get the highest quality results out of your processing.